I'm Erle, and I'm a senior software engineer for Bosch, and I'm also a contributor for an Eclipse project called Vorto, and that's what we are going to talk about today. And forgive me for my, I have a weird accent, so you might not be able to comprehend me much, but I will try. Okay, so we are going to talk today about one of the pain points in developing an IoT solution, which is multiple platforms. So as you can see, there are so many platforms right now coming up. We have AWS IoT. Google is also have an IoT platform. Bosch has an IoT platform, and there's no clear winner. There's no clear dominant platform right now in the space. So there's no default decision. There's no decision you can default to if you want to create a solution. So first, let's define what is an IoT platform. So as you can see, there are devices on the left side, there are applications on the right side, and what sits in between, that humongous cloud that sits in between your data from the IoT devices and the applications that do something about them, that's the IoT platform. Okay? So, yeah, so you have Bosch devices here. Of course, I'm from Bosch. So, yeah, and then you have applications on the other side. So it's also possible for your application to be the IoT platform. So you have your devices talking directly to your application, but that's not really ideal because of many issues. So most applications right now have this architecture where they have an IoT platform in the middle, and you have an IoT device communicating to the IoT platform, and you have applications communicating with the IoT platform. Okay. So you ask, how many IoT platforms are there? So just a very simple Google search will actually give you an idea how many IoT platforms are there. Yeah, so many. And you ask, why is it important to support multiple platforms? So here is an awesome picture of a Venn diagram. Okay, so what I'm trying to say here is that each platform will always try to outdo each other. They will always try to have an edge over the other platforms. So sooner or later, you will have a situation where there are most platforms will have a commonality. They will each have a common function, but each of them will have the uniqueness, their peculiarity, their basically their edge. So consider this. So if I'm an application developer, I want to develop an application, an IoT application, and then I want to integrate device XYZ to my application. But then device XYZ is only talking to IoT platform ABC. So then that means that I have to communicate with the IoT platform ABC in order to integrate device XYZ into my application. Similarly, from the device side, if I want my device to be supported in application XYZ, and the application XYZ is only talking to IoT platform ABC, then I also have to make it sure that my device can talk to IoT platform ABC so that my device can show up in application XYZ. So therein you see that we need to support multiple platforms in order to be able to have as many opportunities as we can, to have as many chance to sell as we can. Okay, so how do we support multiple platforms in the old way? So right now, how do we support multiple platforms? So, yeah, by prodigious coding. We actually code it. Yeah, yeah, he looks really stressed. So yeah, so right now, when you want to support a particular IoT platform, you actually code it. So So now you ask, is there a better way for this? Is there a better way of solving this problem of supporting multiple platform? And yeah, I put there the fundamental theorem of software engineering, which is we can solve any problems by introducing an extra level of interaction. And what is that? So what is the question? What is the better way of supporting multiple platforms? So yes, we propose a solution based on modeling and code generation. So imagine this scenario. You have the device makers creating a model for the capabilities of their device, and then you have IoT platform makers creating a generator for their that will take in a model, and then will produce the integration artifacts for their platform. And then we have the IoT integrators, who will basically get those models, use the generator, and then create the integration artifact, and then we'll code the last 10% in order to make a complete and perfect integration. Okay, so this is the picture that I want to show you. So you have the device makers. They create the device models, the models for the device, and then you have the IoT platforms, and they create the platform generators and then we have the platform integrators where you feed the device model to the generator, and then creates the integration between the device and the IoT platform. So don't you think that's an ideal scenario? So so you ask, if you actually like the situation, so you ask, well, what would make this work? Okay, what would make this kind of scenario work? So in order for this to work, you need to have a common language for creating the model of the capabilities of the device. Okay, so for example, what data does it generate? What are its properties what are the states of this device? What can we do with it? So what are its operations, and what events can it generate? And then after this common language, we also need a repository for storing this. So for storing all these models. And then we also need a generator framework for comprehending this model and then generating the artifacts out of it. And then we also need a repository for these generators. So you have models and a repository for these models. You have generators and a repository for these generators. And then we need the device makers who would want to create models for the device. And then we have IoT platform makers who also would want to create generators for their platform. So these are the things that could make this kind of setup work. And when I say that the device makers create the model, that's not strictly correct. So anybody who are intimately familiar with the device can actually make the model. And same thing for the IoT platform makers. If you know that particular IoT platform intimately, then you can also create the generator. So yeah. So what are the advantages of this? So the advantage is that it's always an advantage to have a common language for describing things, right? And one of the biggest advantage is that integrating devices to platform is quite easy, and it takes lesser effort and is less time consuming. So the use of these code generators to generate platform specific code will significantly reduce development time. It's good for your developers. I'm a developer, so it's good for me. Now, if this common language provides for a way to separate common functionalities as separate entities, then we have a potential for reuse. So if you think about it, there are many concepts in the IoT world that are common. Like, for example, say temperature. A temperature has a value, and it has a unit. So is it the Fahrenheit, Celsius, centigrade? And it has a range. So from what's the minimum range of this temperature and what's the maximum range? And a lot of these pieces of functionality are actually quite common. So if if this particular language has a way of expressing this commonality, and then so there's a potential for reuse. So for example, if your device has a temperature sensor and another device has a temperature sensor, they can um, potentially reuse that reusable pieces of functionality. So so if you're convinced about this, then yeah, so how? This is like the quintessential Singaporean phrase. So how? It really speaks about I want the answer and I want it now. That's well, I'm not really sure if it's correct English, but yeah. So how? And now I talk about Vorto. Okay, so Vorto is all of that and more. So in Vorto, we have this motto called describe, share, and integrate. And for describing, um, Vorto has a language for describing the capabilities of a device. And we have a toolset, a web-based toolset that can allow you to easily create this description. And then afterwards, we go to share. We also have a repository where you can store this definition of the definition of the capabilities of your device, the so-called model. So we have a repository for that. And then for integrate, we have several things. But for this particular talk, we will talk about the code generators, which is yeah, for integrating between devices and platforms. So now we ask the question, what is Vorto? So Vorto is an open source tool, and it's for creating and managing and sharing technology agnostic device descriptions called information models, and then generating source code, documentation, representations out of these device descriptions, and then translate. It's also possible to translate between different device description related standards. So for example, we have IPSO right now. We can convert between IPSO and Vorto. Yeah, so what we are trying to say here is that Vorto is a modeling language, and it uses this concept called information models. Information model actually represents a particular device. So it's basically a real-world device. And then we have a way to store these models, and we have facilities for generating source codes and all of these things out of those models. Okay, so I think the next topic would be, what are these information models? So information models are abstract representations of real objects. So basically, you have a real object, and that, for example, let's say a Roomba. So this Roomba is we can think of this as an information model. And then, yeah, so Vorto is a technical approach to interoperability of different standards at yeah, that's a lot of mumbo jumbo. Okay, so, yeah, so Vorto information models are actually detailed representations of real objects that's following the Vorto meta information model. Okay, and the Vorto repository is actually the one that basically where you can store all of these models, and the generators are the ones that you can use in order to generate the integration between devices and platforms. So and the way and information model is actually a conglomeration of the different another concept called function block. So function block is a reusable component that are referenced by information models. So if you remember what I said about having a wait. Yeah. If you remember what I said about having a facility for creating common functionalities, this is our way of doing it. So the function block is actually the reusable parts of Vorto. So we have information models, and those information models are combinations of several function blocks. So if you think of a device like yeah, let's go again back to Roomba. You can think of a Roomba as having several functionalities. So you have a differential drive that actually makes it move forward, backward, left, right. Yeah, that's one piece of functionality. You can also maybe think that a Roomba has a temperature sensor for its engine. so that it knows when it overheats or when it's okay to run. And we can also think that it has a sensor for checking if it's blocked or not. So all of these functionalities are separate function blocks. And we can also, so for this particular in example, a camera has a location. So basically where it is, X, Y, Z, or latitude, longitude. And then we have the function block for a camera that actually has the image information. And then we have maybe a function block for a motion detector that can detect movements. Yeah, so those are the function blocks of a camera. And yeah, another example. So we have a car. And then, as usual, we have the location function block where it can tell you where it is in the world. And then we have the configuration for this particular car. And then what is its running status? That's also a function block. So as you can see, the function block is actually a reusable components. And this can be referenced by any information model. And the information model is actually the actual device. Okay, so the car is the actual device, and it has many functionalities beneath it. And these functionalities are this unit of functionalities are the function blocks. Okay, so it's difficult to just theoretically talk about this. So maybe we can do a little demo. So remember what I said about this entire thing about you create a model, and then there's a generator that can generate the integration between the model and the IoT platform. So we will try to solidify that, and so you can see how it's actually done. So let's try to build a simple IoT device. I call this a smart scale. It's a connected weighing device. And we will have a hypothetical IoT platform. I call this the Paho Hono Ditto trio. So because it will use the Paho, Eclipse Paho, to as a library in order to communicate with Eclipse Hono. And Eclipse Hono is the messaging platform. And Ditto is the one that actually stores the digital twin, which is the representation of the device in the cloud. So this is its digital twin. So yeah, I call this the Pao Hono Ditto trio. And yeah, we have this device here. It reads the weight, and this is a device, and it sends its data through Paho to Hono, to Eclipse Hono, and then automatically that data from Hono reaches Ditto through a concept they call connections. So Eclipse Hono and no, Eclipse Hono and Eclipse Ditto right now has a connection. I think they just placed that feature there. I think I'm not really sure when they put that feature, but they have a feature that will automatic automatically have a message in Hono reach Ditto. So and then we will then have an application that will query Ditto. So that application is actually just Postman. So the idea is that we have this IoT platform on the middle, and we have a device that's communicating through that IoT platform, and the data from that device will reach the application. And we're gonna do it in a few minutes, so you can see that it's actually a good way to integrate devices to platforms through code generation. So yeah, so the first step is to actually create an information model. And how do you do this? Okay, so let's switch out. Let's go to Borto. So by the way, Borto is in borto.eclipse.org. It's hosted here. And yeah, I hope the internet is fast enough. Okay. How are we doing about time? Oh, okay. Sorry, sorry. Um, okay. How do we do this? Display settings. Okay, I'm not really sure. Maybe I need help. Um, why is it not showing up? So, okay, so the browser. So basically, just the laptop itself, the display. Ah, okay. So it's on a different. Okay, okay, maybe. As you can see, we already have different information models and function blocks there, and those are the. If you look at the, wait, yeah, those function blocks are what you can use in your application. You can actually reuse it, and the information models are the actual the actual device itself. So let's try to log in because I still haven't released my information model. And so right now I'm the only one who can see it. Okay. Oh, this is difficult. Okay. So I've already created it. Just risk reduction. Okay, so yeah, so this is my information model. So this is how I chose to represent my device. I have an information model called Smart Scale, and I have a function block called weight. And if you look at weight, wait, yeah, weight is defined as having a status called sensor value, the actual value of the sensor, and you have the sensor units, which is the unit of the sensor. It could be Fahrenheit, Celsius, and we have the minimum range value and the maximum range value. So this is how I describe the weight, and then the actual device has a weight. So the information model has a function block called weight. So yeah, and okay. So after creating this information model, so what's next? So what's next is actually doing the platform-specific stuff. So for Hono, I'm not sure if you're familiar with Eclipse Hono, you have to do a lot of these REST calls. Or if you're creating your application, you can actually automate this. But yeah, you have to do this stuff. Uh, just I won't be doing this in the sandbox of Eclipse Hono and Eclipse Ditto because those are sandboxes. So I'm actually be doing this in a hosted version of Eclipse Hono, which in Bosch IoT Suite, which is the what we call the Bosch IoT Hub. And Ditto will also be hosted. I will be also using an Eclipse Ditto instance in Bosch IoT Suite, which we call the Bosch IoT Things. So for this, I can, for registering the smart scale in Eclipse Hono and for adding the device credentials, these are the crucial steps which you need to do in order to integrate your device with Eclipse Hono. And these are just basically REST calls. So I've already done it. And then, well, maybe we could just breeze through this faster. Yeah, for the Ditto, you have to do this some stuff. REST calls also. Yeah, you have to create a smart scale in Eclipse Ditto, and then you have to activate the connection between Eclipse Ditto and Hono, and you have to add a policy for Eclipse Hono and the Ditto connector. So these are all platform-specific stuff which you need to do anyway if you want to use Eclipse Ditto and Eclipse Hono. So I'm just gonna use the Bosch IoT Suite right now. So okay, where's my browser? Okay, if you go to the Bosch IoT Suite, you can actually do this. You can click this try, and then it will allow you to register. So you can register through the Bosch IoT suite, and then you can create a subscription for Hub and things. Like I said, Bosch IT Hub is just a version of Eclipse Hono, which we host in Bosch IT Suite, and we have and Bosch IoT Things is also a version of Eclipse Ditto, which we host in the Bosch IoT Suite. So you can subscribe to this. So right now I already have a subscription. So as you can see, the Awesome IoT Day is a hub service. So it contains all my credentials, and the things is also same thing. So I've already pre-registered these devices. So after doing this stuff, what's next? Okay. Okay. Then after doing this stuff, then comes the part where you actually generate the code. So this is basically going to Vorto. Yeah, going to Vorto, and then okay, where's my mouse? Okay, it's actually going to Vorto, and then I have the my model here, and then I can just click on Eclipse Hono, and then it will allow me to choose what kind of integration I want to do. Do I want to do it in Python, Arduino, or Java? Yeah. So we will use Python because I will be running it on a Raspberry Pi, and that's the easiest way to run a code in Raspberry Pi. And then we click on generate code. So as usual, I've already generated it, and yeah, if you click on generate code, it will produce a zip file that contains the actual source code. Okay, but okay, okay, wait. Okay, as you can see, the code is actually quite big. The code is actually you need to complete it. So like I said, the IoT platform maker can actually just create maybe 90% of the code. So they can actually create the connections to their IoT platform, but they don't have a way to know how to actually get the data from a device. So that part you have to do. Okay? So that's basically the last part, the last mile that you have to walk in order to create an actual integration. So you have here the Hono tenant, password, and all that. So this is the platform specific part. And then the rest of the code is for actual sending the data to Hono. So yeah, this code actually it will basically create an information model, and then we'll serialize it on the format that Ditto can understand, and then we will send that payload to Hono, and then through Paho, and then that particular payload will eventually find itself in Eclipse Ditto and will be your digital twin. So it's basically the twin of your device. So yeah, so I have to introduce the device to you. This is a smart scale. This is the scale. As you can see, it's dumb, but if we put Raspberry Pi on this, then it becomes smart. So what this does is actually just getting the load of this particular sensor, and then we will use our Pi GPIO to read this stuff, and then once we get the information, we will then create an information model and send it to Hono, which will eventually find itself in Ditto. Okay, so okay, I have another. Okay, wait. Yeah, so this is just an wait. Hmm, okay, okay. So this is the generated code, right? So you have to modify it in order for it to actually get the information from the sensor. So once you modify it, okay. So yeah, this is the actual thing that I've done. So you have here the information for the Hono information. And then I actually have the scale. This is a library in Python. And then the thing is, there's the way that code works, the generated code works, is it sends data periodically. So it like for every 10 seconds, it reads the sensor data and then sends it. So I have to modify it. So this way, it will only send data when something is actually on it. So you don't have to send data periodically. So yeah, maybe we can do a quick demo on that. Okay, I'm connecting to my Raspberry Pi through serial port. And then, yeah, so the code is already here. And let's run it. Okay, so now I'm connected to Ditto, no, to Hono. And then I maybe place a cell phone on my, yeah. So now it's getting sensor data and it's publishing it to Hono. So let's see if that data actually gets to Ditto. So yeah, no, okay. Let's try to query things to if my, yeah. So as you can see, the sensor value has changed to 3943. Then we try to remove it. Okay. And now it's back to 4. Oops. Okay. And then we try to query it. Yeah, it's back to 4. So yeah, so this is basically the integration between a device and an a hypothetical IoT platform. But that's not really too hypothetical because we are actually doing it. So Hub and things are actually Hono and Ditto. So that's the core of the Bosch IoT suite. And yeah, so right now, what do? You just create your application. You query Ditto. This is Swagger. So basically REST APIs, and then you can query the values from your sensor from here. So we have the device, we have the IoT platform in the middle, we have the applications here, and the applications just query the IoT platform. So I hope you enjoyed that talk, and yeah, any questions? Yeah.
You had to modify the code that's running on the Raspberry Pi. So, how much modification did you have to do? I mean, get some idea of how much work you had to put into that modification.
For modification, the thing is, there are already libraries for this stuff, for the sensors and all. So you just have to integrate it. So, like, if in this case, I only had to do like 10% of the modification. The actual code for sending the device to Hono are generated. So, what the generated code does is it creates an information model, and then sets the values to default values, and then it serializes it and sends it to Hono. And then yeah, so what you will actually need to do is you change those code that gets the values from that creates those information models, and then modify it to get the value from the sensor. So yeah, I can, let's see. Um, okay, this is already a bit change. So yeah, so this part, if this was the generated code, then this was just 1. It's a default value. So um, Yeah, so in order the thing is, this is getting its weight from a queue. So the way I modify this code is I created two threads. One is a producer, one is a consumer. And the producer just constantly query the data and then does some mathematical thing in order to know if the measurement is already stable. And then if the measurement is already stable, it puts that in a queue. And then I have the consumer just basically getting those readings and publishing it. Okay. So yeah. So this is the actual producer. It basically just gets the current measurement, and then it basically checks for the last 10 readings to see if the data is already stable. And then if the data is stable, put it in a queue. And then the consumer will get that from the queue and sends it to Hono. So yeah, for the actual work that needs to be done, it's just very, very, very small. Yeah. Questions anymore?
You said that it publishes the data every 10 seconds when you have something new.
The default code generated, but I already
Gotcha.
changed it. So
You can change it. So you could change it to 1 second or something like
yes,
that?
very much. Yeah.
Very cool.
Okay. Let's look at the. Okay.
Yeah, your original problem statement was that you want to cater for different IoT platform, right?
Yes.
So the IoT platform here is what, Hono?
Hono and Ditto.
Ditto. Both
Yeah.
is IoT platform. So if you want to put it into, let's say, an IBM IoT platform
Yeah.
or HP IoT platform or whichever, then what is the one that's doing the translation? Is it? Sorry, I got confused about
the idea is a generator. So for every platform, you have a particular generator for that platform. So the generator that I just invoked is the generator for this particular Ditto Hono platform. But if you have an IBM IoT platform, then you would have an IBM generator for that, and then this will create the integration artifact. So for example, we have Eclipse CUDA. So we have in order to integrate a device with Eclipse CUDA, it's OSGI based. You have to create an OSGI bundle for it. It's based on Java. So what we do is we create that OSGI bundle for you. So basically, you can just directly put it in CUDA, and you have other integration between your device and Eclipse CUDA.
Can you maybe go back to the Vorto repository and show examples of what's already available out of the box?
Okay. So yeah.
Do you want to try and zoom in, maybe, just a bit?
Okay. Yeah, it's there. So yeah, we have the code generators there.
So you have, go back. AWS IoT, and Kura, Lesson, Google, PTC, ThinkWorks, Samsung Arctic, and this is extensible, right? People can create their own
Yes.
generators, and
Yeah, you can create your own generator and then plug it to us.
we had a question this morning about documentation. I think Bordeaux is one of those projects where you have a really nice documentation on how you can actually build, either use Vorto sort of as an end user and reuse whatever generators are already there, or more as an advanced developer who would require a custom generator. And what does it mean to write a generator? It's also in the documentation, right?
So it's in the interests of a platform provider to provide a code generator for their platform.
Yeah, if you
to
want
make it easier to integrate devices to that platform.
Exactly. That's the whole gist of this talk. It's in the interest of the device makers to create a model, and it's in the interest of the IoT platform makers to create a generator for the platform.
One last question over there. And so did I get that right, that your phone is only 45 milligrams? Or, I want one.
Thank you. Yeah, I'd like to ask a question from the business perspective. So from the multi-platform angle, it is more cost, higher cost as compared to single platform? If I use a single vendor, for example,
Of course.
because a lot of customization looks like required. Am I right?
Yeah, yeah. If you have multiple platforms, then that means you see that that actor they're coding. You will have a lot of people doing that. So more people, more effort, more salaries to give. So more costs. Yeah.
Yeah, and you may have many different devices that you wish to connect to one platform, or you may have just devices coming from one particular vendor, but maybe a variety of platform and end applications that you wish to connect to. So in the end, I guess it's still useful to have something like Vorto, right, to sort of bridge the gaps. All right, so I think that's it for this session. Thank you very much. It was great to have an extra day.
Thank you.